All right, so chapter 13 is titled Vectors and Parametrics. So the first half of the chapter, we're going to learn about vectors. And the second half of the chapter, we're going to learn about parametrics. So lesson 13.1a is titled Vectors. And it's basically an introduction to vectors. And we're going to also talk about the component form and magnitude. So the first thing we want is the definition for a vector, which is an ordered pair of real numbers with direction being what is the angle, and magnitude, that's going to give us the length. And so you're going to see a vector written with this little like half pointy ray thing on top of it. So or you're going to see vectors with what we call the initial point and the terminal point. Sort of like when you see a line can either be with 2 points on it, or you'll see a little lowercase cursive, like line L or line M. Okay, and that's two different ways we can name our vectors. Note the initial point is like the end point, kind of like a ray, and the terminal point has a little arrow on it. Terminal, like when you die, you're terminal, you're dead, that's the end.
Or you could just say you got fired.
Oh, okay.
That's a really dark comparison you got there.
Okay, well, it's true. Okay. All right, so when we talk about standard position of a vector, it's going to be when the initial point is at 0, 0. When the initial point is at 0, 0, makes your life kind of easy. When it's not at 0, 0, you have a little more work to do. And so there's this thing called the component form, and it's going to be with pointy parentheses instead of nice, pretty rounded parentheses, like when you're just given a point in the coordinate plane. The vector brackets tell us the initial point is 0, 0, and the terminal point is at AB, also known as the head minus tails rule. Okay, so we're going to do the terminal minus the initial, and then simplify it, and that's going to put it into component form for us. And we'll get into that, and we'll see that in a minute. All right, so the key point today is that the equivalent vectors are going to have the same component form, meaning they're going to have the same length and the same direction. If you're given a vector in component form, you can find its magnitude, or what is commonly referred to as its length, by using this little formula that looks a little Pythagorean theorem-ish. There's nothing really to write down there. Okay, so let's look at an example down here at the bottom. Okay, so there's a lot going on here. Let me zoom in a little bit, make it a little bigger for you. There's so many things, yes. All right. So you're given 4 points. R is at -4, 2. P is at 2, -1. S is at -1, 6. And Q is at 5, 3. So the first thing you should do is plot all 4 of those points and name them. So 4 to the left, up 2, put a point, call it R. 2 to the right, down 1, plot a point, call it P. 1 to the left, up 6, plot a point, call it S. 5 to the right, up 3, plot a point, call it Q. Okay. Now they want us to prove that the vector RS and the vector PQ are equivalent. So they're putting R and S together. So you're going to have the initial point R and the terminal point S, because S comes second. Then you're going to draw in the vector PQ. So the initial point is P, terminal point is Q. So you draw the little arrow. Okay. We good so far? No? You need help plotting those points? Oh, okay. Do I need to make it even bigger for you? Yes, please. Try. There? Better? Okay. All right, so now we want to show that they are equivalent. So we're going to put them into a component form. So you want to do the terminal minus the initial and the terminal minus the initial. Okay, so for RS, so we need to use these 2 points, and we're going to do -1 minus -4. Now when you have minus a negative, right, you end up actually adding there. So -1 plus 4 would be your 3. And then we do the y values, 6 minus 2, that gets us the 4. So our component form is 3, 4. Make sure your parentheses are pointy. And that tells us how long that vector is. Now we're going to do the same thing with the other vector, which they named PQ. So we want to do the terminal minus the initial. So the terminal is the second one, so Q minus P, so 5 minus 2. That gets us our 3. Then we want to do the y values, 3 minus -1. Actually end up adding them, and we get a 4. So what they want you to notice is that this number, well, this component form and this component form are the same. We showed it mathematically, but graphically, you can also count it out. If you plotted your points on a coordinate plane to go from R to S, you would go 3 this way, up 4. To go from P to Q, 3 this way, up 4. So that's mathematic. Yes. We wrote it down right here. So terminal minus the initial. Yes. So if you haven't written that down, write that down. It's going to be the terminal minus the initial. Okay. All right. Last thing to look at is the last box when we're going to talk about magnitude. They want us to find the magnitude of vector RS and vector PQ. So first we're going to do RS. We put these absolute value bars because it's always going to be a positive measurement, because you can't drive -3 miles somewhere, right? Even if you put your car in reverse, you're still going 3 miles, right? Okay, so for RS, okay, so we're going to take, I have to shrink it just a tad, sorry, to see these numbers. Oh, okay. So see these numbers right here. We're going to take the 3 and square it. We're going to take the 4 and square it. 3 squared is 9. 4 squared is 16. Add them together, you get 25, and the square root of 25 is 5. Now, because we got the same answer for PQ, we should get the same answer for the magnitude of PQ, right? So these two should turn out the same.